You just watched me try to conquer level 65 in Candy Crush Saga. For 22 days, I've been trying to beat this board. Every day we are faced with problems, whether it's trying to beat a level in our favorite video game, or to larger problems like trying to find a cure for cancer. Regardless of the problem, there are a series of steps that we take to solve these problems. We call this a scientific method. In today's lesson, we will review the scientific method and its steps. The scientific method is a logical and systematical way of solving a problem. By the end of today's lesson, I hope that you're able to list and describe the steps of the scientific method. I also hope that in the future you'll be able to carry out your own experiment using the scientific method. The scientific method begins with a question. What does a scientist want to learn more about? We identify our problem in the form of a question, and the question must be testable. Once we've identified our question, we gather information by conducting research. We can go to the library, or we can rely on the internet for more information about our question. Once we've done some research, now we're ready to make a hypothesis. A hypothesis is an educated guess based on our research and prior knowledge about the topic. We state our hypothesis in the form of an if-then statement: I think, I predict, or I believe. Now that we've made our hypothesis, we're ready to conduct an experiment. Now that we have our hypothesis, we're ready to conduct our experiment. Before we can do our experiment, we have to write a list of materials and procedure that we'll need to do the experiment. We make sure that these materials and procedure are very detailed so that anyone following our experiment can get similar results. When we conduct our experiment, we're just testing our hypothesis. During our experiment, we're collecting data and we're also making observations. And we just don't run our experiment once. We run it multiple times. We call these trials. The more we do an experiment, the more reliable our results are. So think about this. There's a drug for the cough. You have a cold, you hear about this drug that can be used to get rid of the cough. Would you take this drug knowing that it's only been tested on 10 people or 1,000 people? Hopefully you said 1,000. So the more trials we can do, the more reliable our results are. Now that we've collected data and observations, we're ready to analyze our data. When we analyze data, we're looking for patterns, trends, relationships between the variables. We're trying to understand that data that we collected during the experiment. After we've analyzed data, we're ready for our conclusion. In our conclusion, we state whether our hypothesis was correct or incorrect. We also try to look for sources of error, things that may have gone wrong in our experiment. We can also look for ways to make our experiment better in the future. And finally, different ways that the information we learned in our experiment can be applied to other scientific problems. Well, that's it for today's lesson. Before you go, don't forget to write at least 5 questions on the left side of your notes, and at the very bottom of your last page of notes, write a summary. Your summary should be at least 2 to 3 sentences summarizing your notes for today. If you can, try to make sure you answer today's aim: what is a scientific method? Tomorrow in class, I'll check to see that you have taken notes for today's lesson. See you tomorrow. Have a good evening. Bye-bye.